Hi everyone, this is Poynting Theorem and you're watching video lecture series on field theory. Today we are going to discuss about the unit 5 topic of electromagnetic waves of Poynting vector. Come, let's go into the video. So Poynting vector. What do you mean by Poynting vector? For Poynting vector, this is one of the important topic in fifth unit. So Poynting vector. So Poynting vector that is represented by S, Poynting vector is represented by S is defined as the cross product of a vector. Defined as the cross product of a vector E and H. Cross product of vector E and H. The direction of power flow at any point is normal to both E and H vector, to the both E vector and H vector. So electric field intensity, magnetic field intensity. The this unit is what? This unit is what? So the S is the Poynting vector that is equal to E vector, that is electric field intensity into magnetic field intensity, the cross product of electric field intensity into magnetic field intensity. The Poynting theorem from Maxwell equations. So Maxwell equations, the Poynting form, the Maxwell equation, the Poynting form, that is nothing but differential form, that is nothing but differential form. That is nothing but differential form. And the equation is what is this the del vector. What is this is magnetic field intensity. Magnetic field intensity, what is this is the cross product of, that is cross product of magnetic field intensity is equal to J into magnetic flux density with respect to time. Magnetic flux density with respect to time. Here, taking the dot product, what happens if it is in a dot product? What happens is that taking the dot product with E on both sides, dot product with E. So now we are taking the in previous equation. What happening here? It is we are taking the dot product of E in the both side. Dot product of E in the both side. What happens from the vector identity? What happens? Dot product of this vector and this dot product of this vector identity. This is what an vector identity. Then the equation 2 becomes what happens? This dot product of vector identity. So H into dot product of electric field intensity minus dot del operator of E into H. This becomes the equation number 2. And substitute equation 2 in 1, then the equation gets what is here? It is this is equation 1. Substitute this equation 2. What is the equation number 2? This is substitute the value of E of del cross H, del cross H value in 1. What happens? Here it is. So in equation number 3, substitute equation 2 in 1. What happens is this, this we will be getting this equations. We are applying. So we are applying this. We are replacing this with here. You can see. So what happens here? It is we are replacing this with del cross E. So del cross E. So we're replacing this del cross E. What happens? We are getting this equation number 3. So from Maxwell equation, del cross E is equal to minus change in magnetic flux density with respect to time. So here H of this value minus H of, now replacing this value H of this value, what happens here? Replacing, we are getting this equation. We are replacing here this instead of this. We are replacing. What happens? We are getting this Maxwell's equations. Okay. Now that the equation 4, this comes the equation. This comes here. Comes the equation 4. Here comes the equation 4. So dot product of this vector is equal to minus E. Minus E into J minus H into, so cross multiplication of this terms and substituting J equal to substituting J. So we know that the J value, J equal to conductivity into electric field intensity, and D equal to epsilon into E, and B equal to mu H. So substituting in this equation, number 4, what happens here? It is we are substituting instead of j, we are del cos E. Already we have an E, so we are getting E square and minus E into. So here we can see instead of B, we are going to substitute, instead of B, we are going to substitute epsilon into E. So what happens? We are taking this E inside. What is happening is for here. So D is equal to epsilon. Now this is with this D, D is equal to epsilon E. So what happens? D is equal to epsilon E, that is E into E with respect to time, and H into, for B, we are replacing new H with respect to time. And finally, we are getting this equation with respect to this takes place with respect to time. We are getting this equation. This is what equation, and this is what the final equation for a Poynting vector. So we can see in detail about the, so integrating throughout the volume, integrating the entire equation with respect to the volume. What happens is dot product of this E into H with respect to volume is a minus of volume of this is what J, this is what the total power is equal to power disruptions, and this is equal to the rate of energy storage, power reception minus rate of energy storage. So using divergence theorem, surface integral is equal to volume integral with respect to magnetic field density here with respect to dot product of magnetic field density with respect to volume. Here D we can replace by del into, for volume integral where D can replaced by E into H. Here the surface integral D, this is also represented by E into H. This is in the using divergence form. This is what, and power of coaxial cable. Here we can see the power of coaxial cable, and this part in next video. Thank you so much for watching this video.